Hey folks, welcome back to Chapter 5, Physics 11. We are looking at Newton's laws. And I've got another example here. We'll come up with a few practice questions. Here's the scenario. Let's try this out. We have a 55 Newton force being applied to a 14 kilogram box, and that's going to cause the box to accelerate at 3 meters per second squared. So take a minute, write that down. There are no questions yet, so let's make up a couple of them. In fact, let me even go back. Let's try to make this question a little bit inclusive here. So it includes a bunch of information we've seen before. Why don't we start with this? Let's start by finding the weight of the box. Now remember, this is like a working definition type question. I'm never going to make you define what the weight is, but you do need to know it so that you can solve a question like this one. And some people might be looking at that 14 kilograms and saying, well, there's your weight right there. But remember, there is a bit of a terminology difference here. 14 kilograms is mass. And outside of our physics classroom, we're going to let mass and weight sort of be interchangeable. We'll let things slide. But for us in the physics classroom, we do need to know the difference. So masses are measured in kilograms. Weights are measured in newtons. And that's because when you're asked to find weight, that is simply a question asking you to find Fg. So weight is the force of gravity. Now, hopefully you remember that the force of gravity is not 9.8. That is simply the gravitational field strength. The force of gravity acting on an object, for any object on the surface of the Earth, we had an awesome little shortcut. It's not just 9.8, it's mass times 9.8. It's m times g. So in this case, we need to take our 14 kilograms, multiply by little g, which was called the gravitational field strength. It's just a number that tells you how strong gravity is on planet Earth anyways, 9.8 newtons per kilogram. And let's try this thing out. Sorry for the little pause there, trying to get my computer working. 14 times 9.8. Let's hit our 3 sig figs. Let's call the weight of this object 137. And that'll be N for newtons. So, going back to the first part of this chapter, we need to know the difference between weight and mass. All right, let's continue. Let's do this. Let's find the force of friction. Now, some of you, when you see the force of friction, you're going to go equation hunting. You're going to say, I've seen that equation before. It's on my formula sheet. Used it in my practice. FF equals the coefficient of friction times the normal force. And hopefully when you're using this equation, you're also looking and going, okay, I remember Heinrich saying this is what it looks like on the formula sheet, but really in practice it's a little bit different because that normal force is equal to mg. So what we end up with in practice is that the force of friction is equal to the coefficient of friction multiplied by mg. And that's awesome. If that's where your brain goes right off the bat, that's totally fine. But what you're going to notice is we actually run into an issue with this. And that issue is that we're trying to find FF. But we also are not given the coefficient of friction. So in this question, this equation that we've come up with is just not going to work for us. So let's do something different. Let's just think about this in a different way. We were told there was some force being applied to the box, making it accelerate. Sounds like there's a lot of forces acting on this thing. So why don't we sketch ourselves a little free body diagram, and let's see if we can figure out what's going on with all the forces. So we'll draw an FBD. So here's my box, and let's go through the different forces that are acting on this. We know, we found it in part A, that we've got gravity pulling down on the box. We're not up in outer space, so we will have to account for gravity. That's m times g, and we already solved for that number up above. That was 137 newtons. And there's no mention of this box accelerating into the center of the earth or accelerating up into the air. So that means whatever surface it's sitting on that's holding it up, remember that force that just supports things, comes from the ground or tables or chairs? That's called the normal force. And since this object is not accelerating up or down, then we know the normal force has to be equal to the force of gravity. It also has to be 137 newtons. So mathematically, it's kind of cool. Those two are just going to cancel each other out. But we do have some side-to-side forces. The question said that there was an applied force, somebody pulling or pushing with 55 newtons. I'm just going to draw that to the right, keep it positive. And remember that there will be friction fighting you. We're asked to find it. And friction always goes against you. So it's going to point to the left, and I have to just call it FF. Remember, we can't turn that into a number, not quite yet. So that's our free body diagram, and that's the worst case scenario for Physics 11, is to have 4 forces in all directions. If you look at the actual numbers now, and if we use them to try to figure out F net equals ma, it turns out we don't have to worry about all 4 directions, because the 137 down due to gravity cancels out with the 137 newtons upwards from the normal force, the ground holding the box up. So mathematically, those wipe each other out. And now what we're left with is this tug of war. We've got 55 newtons to the right, which is pulling or fighting against this force of friction going to the left. So remember, if we're going to use a free body diagram to find F net, and we've got a tug of war going on like we have here, that tug of war simply means subtract. So I've got 55 newtons fighting against the force of friction, and that's equal to the mass, which we know. Mass was 14. And the acceleration of the crate, which we know. That was 3. And if you step back, this is kind of cool. We actually can solve for FF now, not using this orange equation up above, but we can solve for force of friction using F net equals ma, because we knew everything else that was happening to this object. So in this case, 55 minus FF. Don't get stuck with the algebra here. You know how to do this. I know that you know how to do it. 14 times 3 is 42. And I guess here I want my FF to be positive, so I'm going to add it to the right-hand side. Plus FF. And then I'm going to have to pull that 42 over to the other side. Let's do that with a subtraction. Minus 42. And we're going to end up with force of friction on that side. And 55 minus 42 is 13 N for newtons. So there's our answer to part B. We've got our force of friction. And I'm going to ask you one more question. And some of you probably know what's coming at you next. There was one more thing that I put a little question mark up above on, and that is finding this coefficient of friction. So for part C, let's do this. I'll go back up so we can see the question. Let's find that coefficient of friction. So now when we're looking for the coefficient of friction, now we will have to go back to that friction equation. FF equals the coefficient times the normal force. You could separate the normal force into m times g, or you could just work with it as normal force because we have both of those things labeled on our free body diagram. Should make life pretty darn easy. So we know from part B that the force of friction was 13 newtons. We are looking for that coefficient of friction and the normal force. We had it down here in the picture. There it is, 137. So algebraically, this one's pretty darn nice. Divide both sides by 137. You can even use, what was it, 137.2, I think was the unrounded answer. If you want to go with that answer, or that number for the normal force, that'd be awesome. But it doesn't really matter. 13 divided by, oh yeah, there it is, 137.2. So I might use that number just for fun. There you go. Let's go 2 or 3 sig figs. So the coefficient of friction is 0.095. 0.095. And nice thing about coefficients of friction is that there is no units to worry about. So get your 2 or 3 sig figs and you're gold. So there's another practice question. Stay tuned for another video or two. I'll try to make a few more with a few more examples similar to this. But give some of that FNet equals MA homework a try from boxes 3, 4, and 5. You might not be on 5 yet, depending on when you see this video. But there's lots of practice to try. If you get stuck, don't sweat it. Ask a student or a classmate for help. You can ask myself for help. If I'm not at school, you could even go bug Mr. Gao in room 220. He'd be more than happy to help you out. He teaches the same course. So have fun practicing and playing with FNet equals MA. Take care.